Hi everyone, Mrs. Belo here. In this video, I'm going to be going over some of the important information that you need in order to complete the Simpson's Index Lab. So note that this is a lab that will be graded on completion, and it's a practice to get you ready for the Simpson's Index Lab assessment, which will be graded for accuracy. So before I get into the actual lab calculations, I just want to start with a little bit of background information. So we are going to be talking about biodiversity. So formal definition, biodiversity is the assortment or variety of living things. So we're talking about the biotic factors, the living things in an ecosystem. Now, biodiversity can be influenced by climate, which is controlled by precipitation, temperature, etc. And there are certain parts of the world that do vary in climate and therefore also vary in terms of biodiversity. There are some areas that we call hotspots, and examples of hotspots, literally where it's hot, include tropical rainforest and tropical oceans. Okay, so think your rainforests that get a lot of precipitation and are very hot and humid, and then your tropical oceans, those very beautiful, colorful coral reefs. And these areas typically are going to be closer to the equator. So as you get closer to the equator, you're going to see much more biodiversity, just kind of represented here in this diagram, versus as you get farther away from the equator, so definitely towards the north and although it's not pictured here, the north and the south poles, you're going to see less biodiversity. And by that, I mean less different types of plants and animals. And these hotspots, so the tropical rainforests or tropical oceans, although they don't cover a lot of land or a lot of area on Earth, they do contain most of the Earth's variety of species. They have a large percentage of the planet's species. And unfortunately, some of these areas have come under threat from human activity, pollution, logging, deforestation, overhunting, overfishing. Those things are impacting the species that live there and therefore biodiversity. If you ever decrease biodiversity, this can actually cause a decrease in the ecosystem's stability. When you have a lot more variety of different species, this can help if there is a species that's lost, the ecosystem can cope with it. When you start to take away a lot of different species, that can really affect the overall food chains, food webs, all of those things that are connected to each other. So two ways to look at biodiversity, or two ways that we're going to take into account to measure biodiversity, are species richness and evenness. So species richness is just simply the number of different species in a sample. So in these two communities, they actually have the same richness because they both have 4 different types of trees or 4 different types of species. However, these two communities vary in terms of their evenness, which is the relative abundance of each different kind of species, is the measure of the relative abundance of different species. So the community on the left, community 1, this has a higher evenness because we have literally a even percentage or number of each species. Versus the one on the right, community 2, we see lower evenness. And both of these values have to be taken into account in order to calculate biodiversity. So going back to what I was talking about up here, the importance of biodiversity. Okay, so this video will really hit on this idea here. But go ahead and watch this video about why biodiversity is important, and then answer this question here. So what you will be doing in this lab is calculating Simpson's diversity index. So that is Simpson's diversity index. That's this value here. It's represented with the capital letter D. And this is the equation for it. So it's going to be 1 minus, and then we have this calculation here in parentheses. So this right here means sum. It's summation. It means we're going to be adding all of those different calculations together. Little n is representing the number of a particular species. So little n is going to represent how many of each different species you have, versus capital N is just the total number. This is representing how many organisms you have like all together in that particular sample. And your value for D will always range from 0 to 1. So this value that you get here should always be between 0 and 1. If it's closer to 1, that means you have a higher biodiversity. If it's closer to 0, you have a lower biodiversity. So this video here, make sure you watch that and go ahead and show your work in this space for how to calculate the species diversity. Now in the video, he does use a different, slightly different values for those things. So for D, he has this little S on it. You don't need to include that. And then the N, he has this little I on it. You don't need to include that either. It's just to designate, the little I is just to designate that you're talking about different individual species, and then the S is representing Simpson's index. We don't need to include those in our equation. So you're going to be using, for both of these, D equals 1 minus the summation, little n, and minus 1, divided by big N times big N times n minus 1. Okay, and just don't forget about order of operations. So you're going to practice that here, and then you're going to apply that to an actual set of data down here. So before you go ahead and start doing your calculations, go ahead and answer these 2 questions, or 3 questions, excuse me. And note that we're looking at the same ecosystem. We're looking at the same area, just at 2 different points in time. So you can either compare different areas in terms of biodiversity or the same area to itself at 2 different points in time. So this is the data from 1992, and then this is the data from 2001. And I set the table up this way to make your calculations a little bit easier. So for this column right here, you're simply just going to add up all of those together to calculate big N, and I'm going to do that right now. So I added all of these up, and I got 42. Okay, so you're just going to add all of these up to get your big N, which is how many species do you have all together. Over here, you're going to do each of these calculations with little n. So for example, we have 8, so I would do 8 times 8 minus 1. So that would be 8 times 8 minus 1 is 7. So 8 times 7, which would be 56. And you're going to do that for each of these, and then you're going to add all those up and write that number down here. And I'm going to do that right now. All right, so I went ahead and did that, and I got 140. So I did each of these calculations, n times n minus 1, and then I added them all together and got 140. So now I have all the values I actually need to plug into the Simpson's diversity index equation. So down here in this space, we're going to show our work for that. So D, Simpson's diversity index, equals 1 minus. In the top, it's the summation, which we already did that calculation for. That was 140 because we already did that, divided by this value that we did not calculate yet. So remember, in the bottom, it's that big N, which is 42, and then 42 minus 1, we have to multiply those together, okay? So again, I'm using this equation right here. I already did this part because I used the chart to do that, and now I'm doing this calculation here. All right, so we're going to do, so 42 times 41 minus 1 is, 42 minus 1 is 41, so that's 1,722 divided by 140. So 140 divided by that is going to give me 0.08, and we have to do 1 minus that. So 1 minus 0.08. Here, let's do this. 1 minus 0.08. So 1 minus that is 0.92. And that would be my final answer. And then you're going to do the same thing for the 2001 data. And again, make sure you show your work for that. Then you'll answer question number 3. Was your prediction correct or incorrect? It's okay if you were wrong, no big deal. And then you're going to answer questions 4, 4A, and 5. So was there a change? Yes or no? And then use your Simpson's diversity index number to explain for that. Was there a change in that number? Was there a change in the species diversity? If there was a change, you're going to answer question 4A here and explain why you think that is. Make sure you read all the different parts of the lab, especially this information here, to answer that question. And then during which time period do you think the ecosystem was better able to cope with change?